starting with the next type of chemical reaction. We have covered up the combination reaction. Now we are moving on to the second type of chemical reaction, which is called decomposition reaction. In decomposition reactions, a single reactant breaks to two or more simpler products. Like reactant A decomposes to give simpler products B and C. Example: calcium carbonate, limestone. When we heat it, it will decompose to form calcium oxide and carbon dioxide. Calcium oxide is commonly known as quicklime and calcium carbonate is commonly known as limestone. So on heating, calcium carbonate decomposes to form calcium oxide and carbon dioxide. Next example, water. When we pass electricity through water, on passing electricity, water decomposes to hydrogen and oxygen. By electricity, it will decompose to give hydrogen gas and oxygen gas. Third example, when we take silver bromide and keep it in a sunlight, in presence of sunlight, this will decompose to give silver and bromine gas. So only in presence of sunlight, the silver bromide will decompose to give silver and bromine. So we can say decomposition reactions are of three types. First, thermal decomposition. Thermal decomposition means when the compound decomposes on heating. Thermal means heat. So this is an example of thermal decomposition, that is calcium carbonate on heating will split to form calcium oxide and carbon dioxide. Second type of decomposition is electrolytic decomposition. When compound decomposes by passing electricity. So this example of water decomposing to hydrogen and oxygen is an example of electrolytic decomposition. Third type of decomposition is photolytic decomposition. Photo means light, lytic means breaking. With light, the compound breaks, decomposes. This is an example of photolytic decomposition because silver bromide decomposes in presence of light only. Now we have activities to understand decomposition reactions. First activity, for thermal decomposition, heating of ferrous sulphate. We have to take ferrous sulphate in a dry test tube. In a dry test tube, we are taking ferrous sulphate. Ferrous sulphate has a sea green color. It is a sea green color salt. So this salt of sea green color, light green in color, this we are taking and we have to heat it. So when we heat it, we'll see two things here. First is this green color ferrous sulphate on heating shows water droplets here. Water droplets we'll see here on the walls of the boiling tube. And second change that we'll see is the change in the color of the salt. It will start changing to reddish brown color. It will start changing to which color? A reddish brown color salt will form here like a rust. So we see two changes on heating ferrous sulfate. Ferrous sulfate is sea green color salt. On heating, the water droplets will be there on the walls of the tube, and second thing is the sea green color will start changing to the brown color. This happens because ferrous sulfate, when we heat it, it is a green color salt, changes to iron oxide. Ferrous sulfate on heating changes to ferric oxide or iron oxide. Along with this, there's evolution of sulfur dioxide gas and sulfur trioxide gas. This ferric oxide, this has a reddish brown color. So on heating this ferrous sulfate, it will decompose to form ferric oxide, sulfur dioxide and sulfur trioxide. Since this decomposition takes place on heating, so this is an example of thermal decomposition. But why the water droplets are here? It's actually ferrous sulfate exists as FeSO4.7H2O. There are 7 water molecules also in this salt. These water molecules are known as water of crystallization, which will cover in this chapter only. Then what is the meaning of water of crystallization and all that. So these water molecules which are there in the salt, on heating this salt, these water molecules, they evaporate. When they evaporate, we'll see the water droplets here on the walls of the test tube. So this is the reason why there are water droplets and why sea green color salt on heating changes to the reddish brown color. Moving on to the next activity. Heating of lead nitrate. Lead nitrate is a white color salt. So in a test tube, we are taking this white color lead nitrate, and on heating, let's say this is the white color lead nitrate, and heat this boiling tube. We have to heat it and record the observations. The observations are colorless. This lead nitrate on heating gives a crackling sound, like a glass breaking kind of a sound is there. This is the first observation that we will see. Second change is this colorless salt or white salt will start changing to the yellow color. We'll see a yellow color here. A residue is left here which is of yellow color. Plus we'll see the brown color gas. The brown color gas that will coming out from the test tube. A brown color gas we will see coming out from the test tube. So there are three things: crackling sound, then salt has changed to yellow color, residue, yellow residue is here, the salt left here is of yellow color, and plus we see the brown gas coming out of the test tube. This is because lead nitrate, when we heat it, it decomposes to form lead oxide, which is yellow in color. So this salt has changed to yellow color salt, so that is why it changes to yellow color here. Then nitrogen dioxide gas that is coming out from here, this gas is brown in color. So on heating this, it decomposes to give this gas NO2, so brown color comes out from the test tube. Plus there is oxygen gas. So lead nitrate on heating decomposes to form lead oxide, nitrogen dioxide and oxygen. So yellow color is because of formation of lead oxide, brown gas is because of evolution of nitrogen dioxide gas, and crackling sound is indicating that compound is decomposing, it is breaking, so there is a crackling sound when particles are separating out from each other. Now this is also an example of thermal decomposition since the compound decomposes on heating. So this is the second example, second activity for thermal decomposition reaction. Now moving on to the third activity. Silver chloride in presence of sunlight. For this activity, we are taking silver chloride in a china dish. In china dish, silver chloride we are taking. Again, silver chloride is a white color salt in this. So we have a white color salt in this china dish. Silver chloride. And leave this in a sunlight for some time and observe the changes. We'll see the silver chloride changes its color from white to grey color. What we see here is a grey color salt we'll see here. It will change its color from white to grey color. That is silver chloride, AgCl, in presence of sunlight decomposes to form silver and plus chlorine gas is given. This silver formed here, the grey color that we'll see here is because this white silver chloride has decomposed to silver. Silver is left here, chlorine gas evolves out. So white salt changes to grey color. This is an example of photolytic decomposition because this compound decomposes in presence of sunlight. One more example of photolytic decomposition. Silver bromide in presence of sunlight decomposes to silver plus bromine gas. So the silver will form here and this is silver bromide, white color salt, and on decomposition changes to grey color. This reaction, this particular reaction, this one, silver bromide, this is used in black and white photography. This compound AgBr is used here in the black and white photography. So this is about the photolytic decomposition example. Now moving on to the fourth activity. Example of electrolytic decomposition. Electrolysis of water. When we pass electricity through water. Now for this we have to take a plastic mug. When we take a plastic mug, we have to drill 2 holes at the bottom of this cup. So 2 holes are drilled at the base of this cup here. 2 holes are made here. And in these holes we have to fit a rubber stopper in these holes and insert carbon electrode here. We have to insert a carbon electrode here, that is graphite electrode, and connect these electrodes with a battery. This side we are taking anode and this side we have cathode. The switch here, and here we have a battery. This is plastic mug, then rubber stopper, this is cathode terminal, and this is anode terminal. This is a switch, and here we have a battery. Now we have to fill this mug with water. We have to add acidulated water here. Which water we are taking here? Acidulated water. Now which water is acidulated? A water which has few drops of acid in it. A water which has few drops of acid in it, that is called acidulated water. So why we are adding few drops of acid here? To increase the conduction of water, we have to add few drops of acid here. Now after filling the mug with acidified water, we have to invert two test tubes over these electrodes. Over the electrodes here, we are putting up the test tubes here. We are inverting the test tubes here. And leave this apparatus undisturbed for some time. Observe the changes and record the observations. The observations here are, and what will inference from this, the result from these observations: when electricity is passed through this acidified water, the bubbles of the gas are observed at both the electrodes. We'll see the bubbles forming here at both these electrodes. The bubbles are forming. That shows some gas is evolving out here at these electrodes. The volume of gas collected here at cathode, here the gas collected is double as compared to the volume of gas collected at anode. Now which gas is forming here and which gas is forming here? To check this thing, when burning candle is brought near the mouth of the test tube at cathode, the gas burns with the pop sound. This indicates the gas formed here is which gas? Hydrogen gas. And when burning candle is brought near the mouth of test tube at anode here, the candle glows brighter. This indicates the gas collected in this test tube is oxygen. Oxygen helps in burning. So that is why the burning candle, when brought near the mouth of test tube at anode, it glows brighter. That means water, when we pass electricity through this, it decomposes to form hydrogen and oxygen gas. Hydrogen gas is forming, and plus which gas is forming here? Oxygen gas is forming. This is formed at cathode, hydrogen forms, while oxygen is forming at anode. This is an example of electrolytic decomposition. Why? Because this takes place in presence of electricity only. The water decomposes in presence of electricity. So this is an example of electrolytic decomposition. Now the volume of hydrogen collected here is double than the volume of oxygen. So we get 2 volume of hydrogen while 1 volume of oxygen gas we get. This shows that water is made up of 2 parts of hydrogen and 1 part of oxygen. Hence its formula H2O is justified. So this is about the second type of the chemical reactions, that is the decomposition reactions. Moving on to the third type of chemical reactions, which are called displacement reactions. These reactions are called displacement reactions. Now what is a displacement reaction? A reaction in which a more reactive element displaces the less reactive element from its compound. Like when A is reacted with BC, we get B plus AC. This is compound, this is element. This element, if it is more reactive than this element in compound, it will displace it. It will come in place of this B. So A, C will form and B comes out from this, there is B. But remember, this reaction can take place only if this element is more reactive than the element in the compound. Activity to understand displacement reaction: iron nails dipped in copper sulphate solution. We know copper sulphate solution is blue in color. So we take 2 iron nails here. 2 iron nails we have to take here. 1 iron nail we have to put in a copper sulphate solution. We are putting 1 iron nail in a copper sulphate solution. Approximately in a boiling tube, we take 10 ml of copper sulphate solution, which is blue in color. And 1 iron nail, we have to tie this with a thread and immerse it in copper sulphate solution. So 1 iron nail we are taking and dipping that iron nail here inside this. With a thread we have to hang it here in this one and wait for approximately 20 minutes and keep 1 iron nail outside only for comparison. After 20 minutes, take out this iron nail and compare it with this iron nail that was left outside. What we will see, the iron nail which is outside is greyish black in color, and this iron nail that we'll take out after 20 minutes, the iron nail that we take out after 20 minutes, that will be of which color? That will develop little reddish brown color. Which color it will get? Little reddish brown color will come here. Why is it so? Why this happens? Why the greyish black color of iron nail when dipped in copper sulphate changes to reddish brown color? Because of the reaction, iron nail, that is Fe, reacts with copper sulphate solution. This is more reactive than this element copper in a compound. So this will displace this less reactive element. More reactive metal displaces less reactive metal in the compound. So iron will come here and copper comes out. One observation I told you, that change in the color of iron nail. There is one more observation. This blue color of copper sulphate, this also changes its color. from blue color, this will change to the light green color. This will change from the blue to the light green color. This color from blue changes to light green. Now, this light green color why comes, and why the iron nail will get the reddish brown color here, or you can say the brown color here. The reason is this reaction takes place when iron nail is dipped in copper sulfate. This is blue in color, but now this has changed to ferrous sulfate. Ferrous sulfate, just now we have done, has a light green color, sea green color, light green color this has. So this solution will change to green color. And iron is grayish black in color, has changed to copper here, and copper has which color? That has a reddish brown color. So reddish brown color is because of formation of copper. So this is not iron now. What is here? Now on the iron nail there is a copper deposited here. So this gets which color? Reddish brown color. So this is an activity to explain the displacement reaction when more reactive metal displaces the less reactive metal from its salt solution or from its compound form. After the displacement reactions, moving on to the fourth type of chemical reaction, which is called double displacement reaction. Displacement, but which type of displacement? Double displacement reactions. The reactions in which two compounds react. And how they react? By exchange of ions to form two new compounds. The ions are exchanged and they are forming two new compounds. B is displacing C and this is displacing this D. So B reacts with this thing and A reacts with the D here. So where A from reactant AB is exchanged by C from the reactant CD to form two new compounds BC and AD. The two new compounds will form here when the two compounds react by exchange of ions. Activity to understand this. Reaction between sodium sulfate and barium chloride solutions. We take the solution of sodium sulfate and of barium chloride. Both the solutions are colorless. So in two different test tubes we have to take sodium sulfate and barium chloride. Colorless solutions. These two have colorless. Sodium sulfate dissolved in water, which is colorless. Barium chloride salt dissolved in water. This is also colorless. Now mix the two solutions. Mix the two. When we are mixing up the two solutions, this we pouring into this one, what we will see? On mixing the two solutions, we will see the white precipitate formation. White precipitates, we will see the thick white color particles we will see here. This is because barium chloride solution, when reacts with sodium sulfate solution, double displacement reaction. So this is actually combining with this and these two combine with each other. So barium sulfate is forming plus this formation of NaCl. Barium sulfate is actually in the form of precipitates. It's actually in the form of precipitates and the color is white. So white precipitates that we'll see is because of formation of barium sulfate. So in this reaction, exchange of ions takes place to form new products. Hence, this is a double displacement reaction. One note we have. Normally, in double displacement reaction, insoluble product. Insoluble product is called precipitate. Forms in a double displacement reaction. Normally, this insoluble product called precipitate forms when we have double displacement reaction. One more example of double displacement reaction. When lead nitrate solution, this is also a colorless solution, is mixed with potassium iodide solution, which is also colorless. The two colorless solutions we are mixing. So what happens here? This lead combines with iodide and potassium is combining with the nitrate. So two ions are displacing each other. We are getting lead iodide plus we get potassium nitrate. So these we are getting here. Lead iodide formed here. This is in the form of yellow precipitate. So yellow precipitates they will form because of formation of lead iodide. So this is also an example of double displacement reaction.